In this section, we will learn how to graph a linear inequality. So before we sketch a graph of a linear inequality, let's check the graph of linear equation. So y equals x plus 1. How do you graph this one? Okay, we find x-intercept and the y-intercept, or any 2 points is fine. So okay, let's check the x-intercept. X-intercept is you set the y value equal to 0, then you get the x value. That's the x-intercept. So if y equals 0, then x equals negative 1. So the x-intercept is x is negative 1, y is 0. And y-intercept is set the x value to 0, then you get the y value. So x equals 0, then y equals 0 plus 1, y equals 1. So when x equals 0, y is 1. So this is the y-intercept. So the graph of this linear equation is a straight line that connects these 2 points. So all the solution of this linear equation is all the points on this line. So these points are the solution of this linear equation. But the linear inequality, solution to the linear inequality, let's say y equals greater than, here's another inequality, y is less than something. Then the graph is either, okay, the solution is, okay, draw a linear equation first. So the linear equation is on the left hand. For example of the first one, the linear equation is x-intercept is negative 1, y-intercept is 1. So this is the linear equation, the graph of the linear equation. So let me draw a dotted line. Instead of the solid line, draw a dotted line. So dotted line means the line is not included in the solution because the inequality does not have an equal sign. And the solution of an inequality is either above the line or below the line. Then we have to determine the solution, which side is the solution. So how do we select the solution? The side of the solution. So that means we have to find either above or below. Okay, one way is select any point not on the line. Any point. So let's try this point, the origin. So the origin is not on the line, so let's try this number, this point. X equals 0, y equals 0. So plug in these two values. So y equals 0 and x equals 0. Then this will give us 0 is equal to 1. Okay, this inequality, 0 is 0 greater than 1? This is false. This inequality is false. So the solution that contains this origin, okay, so this is not a solution. So the area, below the line, the area below the line is not a solution. Then the solution is the other side. Greater than, the above the line is the solution. Okay, how about example 3? The example 3 is y is less than. This time same inequality, but the inequality sign is different. So first we draw equation. Y equals, draw a straight line. The straight line is on the number 1. So x-intercept is 1, negative 1, y-intercept is 1. Draw a dotted line. Same thing. Select any point not on the line. Okay, the best one is the origin, 0, 0. And check the inequality. Y equals 0 less than, x equals 0 plus 1. Then 0 is less than 1. So this is true. If this is true, then the solution is the area that contains the point that we just tested. So this point is a solution, then highlight that area. So this is the graph of linear inequality. Okay, in example 2, okay, let's sketch the graph of the first one. X is greater than or equal to -3. Okay, before we sketch this, we have to graph linear equation y equals -3. Let's graph this one first. Then what is the type of this graph? Do you remember the holy vertex? Holy vertex. Okay. So the equation that starts with x, then starts with x, then the graph is a vertical line. So the graph of x equals -3 is a vertical line. 1, 2, 3. When x equals, it's a vertical line passing through whose x value is -3. So this is the vertical line. So this is the graph of x equals -3. Now, the solution is either left or right side of the equation. So let's check. Check any point. Let's check this point. Okay, this is 0. X equals 0. X equals 0. Okay, if x equals 0, then 0 is greater than -3. Is it true? No, this is true. So the point that makes the inequality true is the solution. So the area containing this point is the right side of the line. So this is the solution. So basically, x is greater than means right off this number, actually. Okay, and then we draw the line, solid line. We draw a vertical solid line because there is an equal sign. Equal sign is included in the inequality, so we'll draw the solid line. Solid line means all the points on the line are also included in the solution. Okay, how about the second one? Okay, this is y equals this y, this is x. Okay, the equation is this: y is less than 4. Y is less than 4. Inequality. So in order to find the solution, to sketch the graph of this inequality, first we need to draw the line y equals 4. Y equals 4. Okay, holy vertex. The equation that starts with y is a horizontal line. So it's a horizontal line that passes y equals 4. Let's say this is 4. So I will draw the horizontal line, but the inequality does not have an equation. So I will draw a dotted line, dotted horizontal line. And the solution is either above or below this line, above. So y is less than 4. Let's check any point not on the line. Okay, this is the best one. What's the y value? Y value is, this is 0, 0. Okay, that coordinate is 0, 0. And the y coordinate is 0. So 0 is less than 4. Is this true? Yes, this is true. So the area that contains the point that we just tested is the solution. So it's got to be below the line. But as you can see here, y is less than. Y is less than means less than 4. It should be below, obviously. So the area below the line, dotted line, is the solution. Dotted means the point on the line is not a solution. Again, this is example 3. Here is an inequality. X plus y is greater than 3. So in order to sketch this graph, we need to graph the linear equation first. So let's find out the x-intercept and the y-intercept. Okay, let's find the x-intercept. X-intercept, what do? Set the y value to 0. Okay, I'm sorry for the barking sound. Okay, set the y value to 0, then x plus y equals 0. So x plus 0 equals 0, x equals 0. I'm sorry, not 0. This gotta be 3, right? So x equals 3. So if x is 0, then y is 3. X equals 0, y is 3. Okay, what am I doing? This is not right. Okay, y equals 0, x equals 3. 1, 2, 3. So y equals 3, x equals 0. So this is the x-intercept. How about the y-intercept? Y-intercept, set the x value to 0. All right. Okay, for the x-intercept, for the x-intercept, we're gonna set the y value to 0. Set this y value to 0, then x equals 3. So this is the x-intercept. Okay, y-intercept, set the x value to 0. Set this value equal to 0, then y equals 3. Set x value to 0, then y equals 3. So the y-intercept is x equals 0, y is 3. So this is the y-intercept. And connect these 2 points to draw a straight line. Since the inequality does not have equal sign, we will draw a dotted line. Okay, the reason that we sketch the dotted line is all the points on the line are not solution, not included in the solution. All right, then we need to select the side. Is it above the line or below the line? Which will be the solution. Okay, select any point outside the line. The best one is the origin. So let's try 0, 0. X equals 0, y equals 0. So from the inequality, x equals 0, y equals 0. Why am I still putting zeros? Okay, x plus y is greater than 3. So plug in 0, 0. Then let's check if this is correct. Is 0 greater than 3? Is 0 greater than 3? No, right? No, this is not true. Then the area that contains this point is not a solution. Then the solution is the other side. It's gotta be above the line. So this is the solution. So the graph of this inequality is above the line. And the line is not included in the solution. The line is a dotted line. Okay, let's try another one. Okay, this inequality is x plus y, 2x plus y is less than or equal to 2. Okay, keep in mind that there's equal sign. So when you draw a straight line, we will make it a solid line. So let's graph the line first. So write an equation first, and then find x-intercept, y-intercept, and draw a solid line. Okay, x-intercept. How do you find x-intercept again? Set the y value to 0. Set the y value to 0. So let me set this one equal to 0, then x equals. Okay, let me write it down here. 2x plus 0 is equal to 2. Then 2x equals 2. Divide each side by 2. Each side by 2, then x equals 1. Each side by 2, then x equals 1. So x-intercept is 1, 0. X equals 1, y equals 0. X-intercept. How about the y-intercept? Set the x value to 0, then we get the y value. Set the x value to 0. So this one to 0. Then 0 plus y equals 2. So y equals 2. So the y-intercept is x equals 0, y is 2 over here. So draw a straight line, which is a solid line because there is an equal sign. So this is the line graph of this linear equation. And then we have to select, since this is inequality, we have to select the area either above or below. So we can check any point. The best point is what? The origin. So let's try this point. So from the equation, from the inequality, x equals 0, y equals 0 is less than 2. Let's check if this is correct. Then 0 is less than or equal to 2. So this inequality is true, which means the area containing the point that we just tested is the solution. Then highlight this area. Okay. So the graph of this inequality is below the line, including the straight line. So straight line is a solid line. Okay, in this example, we will try to find the solution of the linear inequality in another method. Okay, first we have to draw a straight line first. So let's find x-intercept and y-intercept. Okay, so from the equation, we can find x-intercept and y-intercept. Okay, for x-intercept, set the y value to 0, set this y value to 0, then x equals 15 over 2. 15 over 2. And y-intercept is, when x equals 0, we find y value. X equals 0, 2x equals 0, then y equals 15 over 3 is 5. Then you can graph this one. Let me graph it on here, this side. So x equals, the x-intercept is 15 over 2, so 7 and 8, between 7 and 8, 7.5. So that is 15 over 2, x-intercept. Y-intercept is x equals 0, y is 5. Let's say this point is 5. So that we can draw a straight line. Since there's equal sign, we will draw a solid straight line, solid line. Okay, and then we will use a different method to find the area, the solution. It should be either above or below. But as you can see in this instruction, okay, I will rewrite the inequality. Rewrite the inequality. That means inequality in slope-intercept form. Slope-intercept form. Then it will be y is less than or greater than something. Y equals something, or y is less than or greater. So let me rewrite the inequality. So this is the inequality. So I'm going to write y on the left hand side and all others on the right hand side. So move 2x to the other side. Then negative 3y is less than or equal to negative 2x plus 15. Okay, the left side must have the variable y, only the variable y. We have to get rid of this coefficient negative 3. So we will divide each side by negative 3. So each side by negative 3. Then what happens to the inequality symbol? We have to reverse the direction of the inequality symbol because we are dividing the inequality by a negative number. So negative 2 over negative 3, x 15 over negative 3. Then y is greater than or equal to positive 2/3 x minus 5. Okay. So this is slope-intercept form. And okay, look at the number 2 instruction. Okay, if y is less than, if the inequality is y is less than, then the solution is below the line. If the inequality is y is greater than, the solution is above the line. So as you can see here, y is greater than. So the solution is above the line. And the line is included because the line is solid also because there is an equal sign. Okay, let's make sure if this is correct. Okay, we can try substituting any point not on the line. So let's try this point, 0, 0. X equals 0, 0. Let's apply this point, 0, 0. Then the inequality is 2 times 0 minus 3 times 0 is less than or equal to 15. Let's check if this is correct. Okay, 0 minus 0 is 0. Then that is less than 15. Less than or equal to 15. Uh-oh. Okay, 0, 0 is less. This is true. Then the solution should be below the line. Wait a minute, something's wrong. Something's wrong over here. Let me check what happened. Okay, I found the mistake. Now I copied the question incorrectly. So look at this part. Okay, the inequality is 2x minus 3y, but this is 2x plus 3y. This should be minus 3y. Minus. Then the x-intercept should be y equals 0, then x equals 15 over 2. If for the y-intercept, y equals 0, then x is negative 5. Negative 5. So let me erase this graph. So let me plot the point. So x-axis, y-axis. Okay, x-intercept is 7.5. So that is 7, 8. This is the x-intercept. 15 over 2. And the y-intercept is negative 5. This is y-intercept. So draw a straight line, solid straight line. Okay. And then, okay, the bottom. So when we, okay, for this is correct. You know, this one is correct. I correctly copied the question. So from this one, rewrite the inequality in slope-intercept form. Then y is greater than or equal to. So since y is greater than, we will select the area above the line. Select the area above the line, like this. So the graph is above the line, including this solid line. Okay, using testing any point on the line, any point outside the line. Let's try 0, 0, 0, 0. Then when x equals 0, y equals 0, then the left-hand side is 0. 0 is less than or equal to 15. This is true. So the area that contains the origin 0, 0 is the solution. So this is a solution. Then the area containing this point is the solution. Okay, including the solid line. I'm sorry for the mistake. I copied incorrectly the question. Okay. Okay, as a summary of sketching the graph of linear inequality, okay, first we have to replace the inequality sign with an equal sign so that we can sketch the straight line first. So sketch the graph, a straight line using either using x-intercept and y-intercept or using slope method, doesn't matter. So draw a straight line first. And the straight line will be a dashed line if there is no equal sign. And if there is an equal sign in the inequality, then use solid line. Okay, and then finally we have to select either side of the line, either above or below the line. So we have to shade the line, half the plane, either above or below the line, by testing a point. So if a point satisfies the inequality, then that area containing the point is the solution. Or you can try rewrite the inequality in slope-intercept form. So slope-intercept form is, y is greater or something, y is less than something. So if y is greater than, if we have a symbol greater than, then select the area above the line. So shade that area. If y is less than, then select the area below the line. So make sure you cannot have y, something like y equals 2y is greater than something. This is not right. You must have y is greater than or y is less than.